This lesson is on 5.7, Exponential Equations and Applications. The homework that's listed we will be doing in class together on the next day that I see you. Our first slide talks about exponential equations. These are equations that contain a variable in the exponent. We've done a lot of these when we did a of t is a0, 1 plus r to the t, and we were trying to find what the t was. So to do this, you can either express both sides as powers of the same base, and you wouldn't need a calculator for that, or you can use logs by taking the log of both sides of the equation. So let's do these middle problems. Why don't you press pause and see if you can put those into the same base first. Okay, the first equation is 2 to the t minus 3 is equal to 8. And 8 can be rewritten as 2 cubed. So once you have the base the same, we can just set these two equal, which we've been doing in class. So t minus 3 will equal 3. You add 3 and t is 6. Okay, the next equation is 9 to the 2t equals 3 times the cubed root of 3. So we're going to put these both in base of 3. 9 is going to become 3 squared to the 2t. And this is going to be 3 to the first times 3 to the 1/3. Remember that when you're raising to a power, you're going to multiply. So this becomes 3 to the 4t. And when you're multiplying, you're going to add those powers. So 1 is really just 3/3. So this becomes 3 to the 4/3. Now you've got two bases that are equal. So you could set those powers equal to each other. 4t is equal to 4/3. I could divide by 4, but you don't want to go through the process of dividing by 4, so just multiply by 1/4, and then you'll see the answer a lot quicker. So the 4's will reduce out, t is equal to 1/3. Okay? So just remember your rules of exponents when you're doing these problems and put them in the same bases. And remember, we're not going to use any bases other than 2, 3, and 5. So don't go looking for other numbers other than that. So now we have example 1. I want you to solve these we're going to have to use a calculator. And why do we need to use a calculator? Because we can't put them to the same base. So to undo something that has an exponent, if you remember back to the a to the t problems, we took the log of both sides. So if I write the log of 25 to the x equals the log of 3, you could go through and with your powers of exponent or powers of logs, you know that that can come out front, and it becomes x log of 25 equals the log of 3. And to solve for x, we're just going to divide by the log of 25. You'll use your calculator. Make sure you use a lot of parentheses and things like that. You're going to get 0.3413. Okay? So on this one, you could take the 8 and make it 2 to the 3x, but because they don't have the same base, don't do extra steps for yourself. You're just going to go through and do the log of both sides. So the log of 8 to the x equals the log of 5 to the 1/3. And those powers will both come down. So I'll write them in red. So we have x times the log of 8 equals 1/3 times the log of 5. We're still solving for x, so we're going to still just divide by the log of 8. And using your calculator, just do 1/3 times the log of 5 divided by the log of 8, and you should get 0.2580. When you're doing them, go to 4 decimal places, okay? If you're having any problems using your calculator, we can address that the next time I see you as well. Just jot some notes down that you had a problem with getting the answer to this one. So there's a formula called the change of base formula, and you use this when you want to change to base 10 so that you'd be able to use your calculator. It's sensical, so I'm not going to be giving this formula on the test to you, so you need to make sure you understand how we did the problem, okay? If you have log base 7 of 2, you're just going to set it equal to x, so I did that right here. And then you use your swirly method if you want, so you're going to go 7 to the x is equal to 2, and that's this one. Because I have the exponent to the power, I'm going to take the log of both sides. That's that step. The x is going to come forward, so I get x log 7 equals log 2, and then I can just divide both by log 7 to get x to be log 2 over log 7. So if we remember right, x is equal, like from up here, to the log base 7 of 2. So therefore, the log base 7 of 2 is equal to log 2 over log 7. And if you notice, these logs, 2 and log 7, are in base 10, so you'd be able to use your calculator to find an actual answer. Okay, I'm going to take you through both methods to solve these. So I'll use the change of base formula really quick to solve them, and then I'll go through and show them how to do it by hand in case you forget the change of base formula or you just want to check your answer if you have extra time on the test. So right now we have this, and it's the log of 9 over the log of 2. I'm going to go to 4 decimal places, so I have 0.9542 over 0.3010. And when you're rounding at this final answer, you can go to 2 decimal places, so you should get 3.17. The next one is the log of 6 over the log of 5, and that'll give me 0.7782 over 0.6990, which you get 1.11. So that's how to do it quick and easy. I'm going to show you again how to do it. I'll just do one of them, but I'll show you how to do it by hand if you just forgot. Okay, so say I forgot the formula and I needed to do log base 2 of 9. I will set the log base 2 of 9 equal to x. Once I've done that, then I'm going to go through and write my exponential. So I'm going to say 2 to the x is equal to 9. I will take the log of both sides, so I'll say the log of 2 to the x equals the log of 9. So now I'm in base 10. I'm going to bring this x forward, so I'll have x log of 2 equals the log of 9, and then I just divide by the log of 2. And I'm at the same point where I was before, so I will just get the 3.17. Okay? So if you forget the change of base, or if you're just not sure, it's a good way to check yourself. Okay, so this slide just goes through the use of logs to solve exponential equations and applications, and it's really what we've been doing. If you have 1.5 equals 1.08 to the t, and you're trying to solve for t, you're just going to take the log of both sides, which is done in here. The t moves forward, so that's this step. And then you're just dividing by the log of 1.08. So you'll get 5 years. So it definitely has applications in real life. and let's move to solve some problems. Okay, so in 1990, there were 5.4 billion people in the world. If the population has been growing at 1.9% per year, when will the population be 8 billion? So we know we're going to use this equation because it didn't talk anything about compounded. It's not continuously, so it's just a strict kind of rate problem. So going through the problem, 1990, there were 5.4 billion. So this is going to be when my time is 0, and this is my A0. This 1.95 is going to be the R, and I'm going to put 0.0195. So far, and when would the population be 8 billion? Well, that's my A. It's my A of t, and t is what we don't know. So I'm going to set up the equation as 8 is equal to 5.4 times 1.0195 to the t. From there, you're just going to isolate. Your goal is to get this isolated. So I'm going to divide by 5.4. And that gives me 1.4815 equals 1.0195 to the t. Okay, I needed a little more space. So remembering back, I'm just going to take the log of both sides. 1.4815, sorry about that, is equal to the log of 1.0195 to the t. That will move this out front, and from there I can just divide by the log of 1.0195. And t will equal approximately 20 years. So you're not really done because you want to make sure it says when will it? Well, it's 20 years from 1990. So 1990 plus 20 is going to be 2010. And that's the answer you're going to give. One thing to be really careful about is this is not subtraction. It's only subtraction if you had the log of 1.4815 over 1.0195. But because both of them have logs, you're going to just divide them. Okay? So just be careful on that point. Okay, so this problem says if you invest $100 at 6% compounded monthly, so we've got compounded monthly, when will it be worth $150? So if I'm going to go with this equation, and my A0 is going to be the 100, my R is 0.06, and my N is 12 because it's compounded monthly. T is what we're trying to find, so my A is 150. So I'll set up the equation. 150 is equal to 100 times 1 plus 0.06 over 12 to the 12 times t. So if I divide by 100, that gives me 1.5 is equal to 1.005 to the 12t. Because my t is in the exponent, I'm going to go through and take the log of both sides. And if you remember, this is going to bring this out front. So I'll have the log of 1.5 equals 12t times the log of 1.005. I'll divide by the log of 1.005. and that gives me 81.2956 approximately. You can leave the whole number on your calculator. You don't have to write out these intermediary steps if you don't want. That equals 12t, and then I divide by 12, and I get t is approximately 6.77 years. And there you go. So I'll see you in class the next time we have class, and if you have questions on any of these things, just make sure you bring your questions to class, jot them down on the paper now so that you'll remember that you have a question. And we bring your book to class, and we will do the assignment in class.